A set is a collection of distinct and well-defined objects, which can be anything from numbers, letters, elements, or even other sets, and are denoted by curly braces. And we have basic operation sets. In basic operation sets, we have union, which combines all elements from two or more sets. The intersections show the elements that two sets have in common. We have basic sets operation. In basic set operation, we have the union, which combines all elements from two sets or more sets. And then we have intersection, shows the elements that two sets have in common. Then complement shows the element not in the set but in the universal set. Then we have the relation, shows a connection or relationship between two sets of elements. It tells how the elements of one set are related to the elements of another set. We have the reflexive relation. A reflexive relation means that every element is related to itself. Then we have the symmetric relations. A symmetric relations means that if one element is related to another, then the second element is also related to the first. Then we have the transitive relation, means that if one element is related to a second, and that second element is related to a third, then the first element is also related to the third. A proposition is a statement that can be either true or false, but not both. Then we have logical connectiveness. Words or symbols used to combine or relate propositions to form more complex statements.
Not represents negation, and represents conjunction, or represents disjunction, implies represents implication, if and only if represents biconditional.
Now we have the direct proof, which you start with known facts or assumption and use logical steps to show that the statement is true. Proof by contrapositive works by proving the opposite form of a statement instead of the statement itself. Both are logically the same, meaning if one is true, the other is also true. Then we have proof by contradiction. You assume the opposite that you want to prove and show that this assumption leads to a contradiction. So the original statement must be true. Then mathematical induction. You prove a statement for the first case or base case, then show that if it's true for one case, you also true for the next inductive step. This proven it's true for all cases. Then next we have the permutation, which is the arrangement of objects in a specific order, but order matters. Combination, the selection of object without caring about order. Order does not matter. Then we have the predicate, a statement of function that becomes true or false depending on the value of the variable. And then quantifiers, symbols that tell how many elements in a set make the predicate true. Universal quantifier means for all or for every. It states that the condition is true for all elements in a given set. Then existential quantifier means there exists. It states that there is at least one element in the set that makes the statements true. Then we have the set theory. Set theory is the study of sets, which are collections of objects or elements that helps describe relationships between groups of items using operations like union, intersection, and complement. And we have also the combinatorics, which is the branch of mathematics that deals with counting, arranging, and selecting objects. It includes concepts like permutations and combinations. The a relation shows a connection between two sets by pairing elements from one set with element from another. And in functions, a special type of relations where each element in the first set is paired with exactly one element in the second set.